This presentation is entitled Modern Physics and the Philosophy of Science. It's based on a book which I wrote recently entitled The Language and Logic of Physics, Metaphysics, and Mysticism. And the theme of this presentation is that modern physics has largely left the scientific method and has moved in the direction of metaphysics and mysticism. The basic questions of this presentation on the philosophy of physics are: does modern physics, relativity, and quantum mechanics follow the scientific method? 2, does modern physics involve metaphysics and even mysticism in lieu of empiricism, which is the foundation of science? Does the language and logic of physics accurately describe the phenomena it studies? Does modern physics require a different kind of logic and a different methodology from classical physics and other sciences? What are the implications of these questions for sound scientific theory? Definitions that relate to epistemology, that is, what is reality? The basic philosophical question. Physics is the study of physical things, matter, mass, energy, forces operating in space and time, that is, material reality. At least this is what classical physics studied. Metaphysics, which is mental reality, the products of the mind, abstractions, concepts that can be purely imaginary or representations of the physical world. They are epiphenomena that we superimpose on the physical world to organize our perceptions of it. For example, the lines on a globe that organize our observations of the Earth are epiphenomena and therefore metaphysical. The map is not the territory, and the globe is not the Earth. Representations of physical phenomena are approximations of physical reality. The tools of metaphysics include language and mathematics that describe the universe. Mysticism, on the other hand, is so-called higher truth that transcends rational understanding and may involve non-material or spiritual concepts of reality. Mysticism usually indicates that the physical world is illusion and that everything is one. Separateness is illusion and the cause of suffering. Contradictions can coexist in mysticism, and it believes in a truth beyond dualities and contradictions. There are several definitions of metaphysics. For this work, I am using Immanuel Kant's definition of metaphysics as nothing more than the inventory of all that is given to us by pure reason, systematically arranged. That is, the products of the mind, pure imagination, or a conceptual grid we impose on the physical world, such as a grid in space. Metaphysics, on the one hand, is rational and logical. Mysticism, on the other hand, is not rational because it involves contradictions that supposedly are transcended by our truth. In distinguishing the physical from the metaphysical, let's look at the continuum of reality from the physical to the metaphysical. And we see that it involves matter, energy, space, and time. On the left side of this continuum, we have the physical realm, matter and energy. These are things that are visible, or at least you can see visible results of their interaction. On the right side, we see space and time, which are metaphysical and abstract concepts. They involve things that are invisible, impalpable, and therefore they are things of the mind rather than the physical world. Then underlying all of this is our consciousness, by which we perceive all of these interactions. And proceeding from left to right, the concepts become more metaphysical or abstract and less tangible and physical. Although these phenomena exist without our consciousness, our minds represent them with symbols which shape the way we perceive them. Science assumes objective reality versus subjective reality. In other words, science and scientific realism assumes that the objective world is real. It is not Maya, and it exists independently of our consciousness. Here we see a triangle which represents the various levels of theory and how theories are made. At the very base of the triangle, we see unstated premises. These are assumptions. Many times these are unconscious. And then one step above that, we see the stated premises of the theory using language and logic. At the third level, we see concepts with mathematical modeling. In physics, mathematics are brought in at this point. In other sciences, mathematics are brought in after the collection of data. The next level would be hypotheses, and to be a good hypothesis, it must be falsifiable. It cannot be unfalsifiable. At the top level, we see theory, which is based upon several hypotheses which have found some evidence or empirical validation. And when a theory is absolutely proven, we have a law. As imagine, we don't have a whole lot of laws in science. There are things that are stated as laws, such as the law of conservation of mass and energy. I would prefer to call these principles rather than laws. String theory is a good example of how mathematics may be used to the exclusion of precise language, logic, and observation. It's a good example of what I mean by many theories in physics not being scientific, not following the scientific method. String theory is founded on the premise that there are tiny, invisible, one-dimensional strings that vibrate at different frequencies in 11 dimensions to produce the various particles known to physics. Is there any direct or indirect empirical evidence for one-dimensional strings or extra dimensions beyond the 3 spatial dimensions we experience every day? Yet some physicists defend the theory, saying that it has produced some new mathematics in the field of topology, but topology is pure math, not physical reality, that is physics. Chess math is an example. One can create a math surrounding the game of chess, program that into a computer, and beat the world's chess champion Garry Kasparov. Yet we know that chess math does not represent any physical systems in the natural world. Much of modern physics, such as string theory, is mathematical metaphysics, not real physics. In other words, I would call it chess math. Mathematics is metaphysical. It's not a physical reality. Math is a wonderful tool, but qualitative language must precede quantitative language or math. Again, if space and time are not what Einstein says they are, then relativity can be questioned. Math, like qualitative language, is a representation of reality, not reality itself. Thus, it is metaphysical. Feynman said, in fact, everything we know is only some kind of approximation, because we know that we do not know all the laws as yet. However, some physicists believe that math is reality. All structures that exist mathematically exist also physically, according to Max Tegmark, a physicist. And physicist Paul Davies says that many of my theoretical physicist colleagues do indeed regard ultimate reality as vested in mathematics that describes physical law. The logical conclusion is to treat the physical universe as if it is simply mathematics. And string theory, again, is a good example of a mathematical theory that has not found any empirical basis. Einstein himself recognized the limits of math in describing physical reality. Einstein's comment to a colleague was, "Your math is correct, but your physics is abominable." Thus, he recognizes the difference between mathematical or metaphysical reality and physical reality. Einstein also said, "The important thing is the physical picture. Math is nothing but bookkeeping." Yet relativity, general relativity in particular, is highly mathematical, and it is often claimed that since the math works, the theory is correct. The question is, what is science, and what branch of philosophy is the basis of the scientific method? The branch of philosophy called epistemology, how we know what we know, provides the basis of the scientific method. The specific philosophy of science is called rational empiricism or logical positivism. Now sometimes it's called scientific realism. Rational empiricism means that logic or rationalism and observation empiricism work together to form a sound scientific theory. Rational empiricism is based on the assumption that the physical world is real, not an illusion, and that observation of the physical world is the ultimate test of truth, not pure logic. Metaphysics Classical Greek philosophy was based on pure rationalism or metaphysics, and measurement was considered to be an approximation. Plato said that perfect forms exist in the mind, and the world of the senses, empirical world, is an imperfect reflection of those perfect forms or truths. Since Greek metaphysics indicated that truth can be derived in the mind by logic alone, without reference to observation, Aristotle concluded that an object weighing 10 times more than another object would fall 10 times faster. Galileo, on the other hand, used rational empiricism. First, he used logic to pose a crucial question. If you tie a 1-pound weight to a 10-pound weight, would the 1-pound weight subtract from the velocity of the 10-pound weight? Or would the 10-pound weight and 1-pound weight be added together to produce an 11-pound weight, which would fall even faster than the 10-pound weight? However, Galileo, unlike Aristotle, did not stop with reasoning about the issue. He is alleged to have set up an experiment in which he dropped a 1-pound weight and a 10-pound weight from the Leaning Tower of Pisa and found that they hit the ground at the same time. Actually, Galileo created inclined planes and rolled balls of various weights down them and deduced the equivalence principle, that all objects fall equally under the force of gravity in a vacuum, that is, discounting air resistance. Physics and metaphysics, their relationship to science. Physics based on pure math is metaphysics, not true physics. Metaphysics alone is equal to pure math or pure philosophy, such as that used by Aristotle or Pythagoras in the Greek tradition. Metaphysics plus physics is equal to science, as we saw in the last frame, the kind of process that Galileo used in finding the truth about 1-pound weights and 10-pound weights falling at equal rates of speed. Physical forces can only act on physical objects, and physical forces cannot act on metaphysical things, such as products of the mind. And metaphysical things cannot act upon physical objects. For example, the lines on a globe are metaphysical or epiphenomena. They are not found on the surface of the earth. We superimpose them on the globe. The lines can help us navigate the world, but they cannot act upon or be acted upon by physical forces. The lines cannot make the earth spin. Space and time are also metaphysical concepts or abstractions. Mysticism is based upon the idea that higher truth is transcendental and spiritual, which means that transcendental truth cannot be apprehended by the rational mind. Mysticism also teaches that the physical world is not real, that it's an illusion or maya. Mysticism is also associated with the idea of oneness, where individuality is seen as an illusion, and this sense of separateness causes conflict and pain, as in Buddhism. The following illustrates the three types of thinking, that is, physical, metaphysical, and mystical. A Hindu proverb says, "I exist and don't exist." That would be mysticism, because it involves a contradiction that cannot be resolved rationally. Descartes said, "I think, therefore I exist." That would be metaphysical rationalism, based on pure math or pure philosophy. In this case, it would be based on pure thinking. But it is a highly logical statement that's hard to refute. Rational empiricism would be that I am aware of myself, I feel my body, I see my reflection, therefore I exist because I believe the physical world is real. When I see a reflection and I feel my body, that would be my senses telling me about the physical world. Rational empiricism is based on the assumption that the physical world is real and not an illusion, as I've said. Some physicists have said that modern physics, especially quantum theory, is better understood through Eastern mysticism than Western science. Fritjof Capra, who wrote The Tao of Physics, subscribed to the idea that quantum theory is better explained by Eastern mysticism than Western science. Bohm, Heisenberg, and Bohr also studied Eastern mysticism and had connections with various gurus and mystics. Fritjof Capra's comment on mysticism and physics. He, referring to Heisenberg, said that he was well aware of these parallels. While he was working on quantum theory, he went to India to lecture and was a guest of Tagore. He talked a lot with Tagore about Indian philosophy. Heisenberg told me that these talks had helped him a lot with his work in physics because they showed him that all these new ideas in quantum physics were in fact not all that crazy. He realized that there was in fact a whole culture that subscribed to very similar ideas. Niels Bohr had a similar experience when he went to China. In this slide we see Schrodinger's cat box thought experiment, which is a parody on mysticism and quantum physics. Schrodinger was more of a classicalist, and he was trying to create a reductio ad absurdum to show that quantum physics is mysticism and untenable. Later he said that he wished he had had nothing to do with quantum physics. Well, the experiment, as we see in this little graphic here, involves on the right a radioactive element in a box, such as uranium perhaps, and there's a 50-50 probability that the radioactive element will emit a particle. If it does, it trips a lever which lowers the hammer, which breaks a test tube with a poisonous gas, and if that happens, of course, the cat will die. Well, the cat box is sealed so that the experimenter cannot see what's going on. And the theory of quantum physics is that the cat is both dead and alive until the experimenter opens the box, makes a measurement, and then the experimenter will determine whether the cat is dead or alive by his observation, which implies that consciousness is a very important part of the experiment, and that consciousness and observation is what determines the outcome of the experiment. And here we see that what happens at the quantum level affects what happens at the macro level of reality. In mysticism and quantum mechanics, contradictions can coexist, but in true science, contradictions cannot coexist. Compare the statement, "I exist and don't exist," from Hinduism to "the cat is both dead and alive" until an observation is made. Also consider that particles can be here and there at the same time. Particles can exist and not exist, and can come from the vacuum, that is nothingness. Energy can be borrowed from the vacuum, nothingness. These are Zen koans, in my opinion. A Zen koan would be something like, what is the sound of one hand clapping? We know that's an illogical question. There's no logical answer to it, because you have to have two hands, use two hands to create clapping. The scientific method is based on the premise that hypotheses must be falsifiable. After a research hypothesis is established, a null hypothesis is set up, which is a contradiction of the research hypothesis. If the null hypothesis is not supported by evidence, then there is evidential support for the research hypothesis, since both hypotheses cannot be true. So again, in mysticism, contradictions can coexist and are thought to both be true. In science, contradictions cannot coexist. One is true, the other is false, in a reasonable, good hypothesis. Here is a list of Zen koans that I have found in modern physics. At least I think they are Zen-type koans, based on what is the sound of one hand clapping. Negative mass. How can you have less than zero mass? Negative energy. Once you reach absolute zero on the Kelvin scale, how can you have anything below that, or negative energy? Vacuum energy. Borrowing energy from the vacuum. If it's a true vacuum, it has no energy to lend. And the idea is if you pay it back quickly, then it all amounts to zero, so that the amount of energy borrowed is equal to the amount of energy that's repaid. That equals zero, and so you can get by with vacuum energy. Massless particles. If something is a particle, it must have mass, whether it's an energy particle or a matter particle. Einstein said that energy and mass are interchangeable, and that even energy has mass. Getting something from nothing, a deeper nothing. For example, in the Big Bang Theory, you get something coming from nothing that violates the law of the conservation of mass and energy. Space is expanding. If space is really nothing, emptiness and void, it cannot expand or contract. That would be the sound of one hand clapping. It's illogical. 0 point energy. If you're at a 0 point, there is no energy. Either you have energy or you don't. And a particle must spin twice to make one revolution, and a particle can be here and there at the same time. An example of setting up contradictory hypotheses is the link between cigarette smoking and lung cancer. The research hypothesis might be there is a relationship between smoking and lung cancer. The null hypothesis, on the other hand, would say there is no relationship between smoking and lung cancer. Since both of these hypotheses cannot be true, if a strong statistical relationship is found between smoking and lung cancer, then the null hypothesis is not supported, and the research hypothesis gains credibility. And correlation is not equal to causation. Just because you find a correlation between smoking and lung cancer, that does not prove causation. Other procedures must be used to establish causation. However, in mysticism, contradictory hypotheses can coexist. The cat is both dead and alive. I exist and don't exist. Smoking causes cancer and doesn't cause cancer. Therefore, mysticism does not conform to the scientific method and is thus unscientific. In this slide, we see a summary of what I've been talking about, and I've called it the cyclical history of philosophy. Let's start at the top there with mysticism, which is based on intuition. It's very primal. Early man used mysticism to try to understand the world and his environment. And of course we have Eastern mysticism, but there's also mysticism in Western culture. Eventually that evolved into metaphysics, and we see that Greek rationalism may be the first historical example of metaphysical logic and rationalism. We have Pythagorean numerology, and Pythagoras believed that the ultimate reality is in the mathematics, much like modern physicists. And we find Aristotle making statements based on his reason, but which didn't prove out in the empirical world. Then we have the evolution of rational empiricism, or science, and we've illustrated this with Galileo, who combined metaphysics, that is rationalism, with physics, and this led to the scientific revolution. And you recall that he did the experiment to show that all objects fall at the same rate. He called it the equivalence principle. He didn't stop with logic, he tried it out in reality. Then we have the development of modern physics, and we find a return to mysticism and metaphysics. For example, string theory that we've talked about seems to be purely mathematical metaphysics with no correspondence to reality that's been found. And we find mysticism, as Capra indicated, especially in quantum physics, where contradictions can coexist. And then, of course, we find the completion of the circle there with mysticism and a return to what I call a primal way of thinking. Well, if I may put in a little ad for my book, for more detailed treatment of these topics, please consider my book, The Language and Logic of Physics, Metaphysics, and Mysticism. It's available on Amazon Kindle as an ebook for a free 30-day trial, and a summary is available on academia.com.